So we are going to start the meeting. To those who have joined us, you're very welcome. Those who are, it's the first time for them to join, you're also welcome. And today we'll be talking about serial in kariRS. There are people who are still joining. And so first take you to where we left last time before we start the main agenda for today. Let me take you there very fast. So to share that. So someone to confirm whether you can see my screen, whether you can clearly see my screen. Just unmute your mic and reply. Okay, so I wanted to first touch on something we mentioned last time before getting into what we are intending to do today. Last time there was something I wanted to make clear. Last time we were talking about in the session for the timing in kariRS, we were talking about the kariasync and karipass. And if you are totally new to kariRS and you know nothing about what I'm talking about, we have the live recording sessions on YouTube. I'll be sharing the links in the group or also here if you are completely new, so you can check them out. So there is this part that I just wanted to mention very fast. This is what we did last time. So I just comment out this one. Just comment out these other codes you can see here. Just comment them out. And the last thing that I told you to check about is about this functionality known as carry sequential. So basically what carry sequential is that it is an API which allows you to change the state of the pins sequentially by using smart algorithms in an unblocking manner. You do not use one of the most hazardous things when writing programs is, or when you want to write cryptography relays. So this is one of the ways that kariRS try to solve such kind of things. So you can use kariRS sequential for various things, but here I'm just for demonstration purposes I'm using LEDs so that you can be able to understand what we are really talking about. So I don't think whether I showed you how kariRS sequential works, a demo. Just wanted to show you that demo very fast before we dive into the serial communication. So actually it works the same as calipers. So you initialize your pins like this, as you can see them here. We have pin mode, we have 4, 25, 26. Those are the pins that we'll be using. And actually, in this session, I'll be showing you another way to initialize pins in a one-line code, other than writing all these things that you're seeing here. So here is our kariRS sequential. So you give it an array, that is an array of pins that in which you want it to manage. So the moment you give it these pins, now they belong to it. It is the one that manages those pins. So do not make a mistake of like giving pins to the kariRS sequential and again you come into another task and give them to another API like calipers. You'll be running into trouble. So make sure whatever pins you have allocated to one of these APIs, they will only be using that APIs. And actually kariRS will even prevent you from doing that during compilation. So here, this line of code, I want to make it clear what it means. It means that take these arrays of pins, this list of pins, and assign them to a sequence. When we use the kariRS sequential, we usually give it a name. For example, here we have just named it sequence 1, but I could name it anything. If you want to call it marine, if you want to call it any name, you can give it any name. If you want to call it sequential task like that, you can just name it whatever you want. And now, I believe there's could be someone pretty new to this syntax, so I'll mention just what this is, although this is not the scope for today. We have this we call kariAsync. This function you can see here, it is known as kariAsync, and basically it is a macro which is what we use as the scheduler in kariRS. It is the one that schedules tasks. It is the one that tells the microcontroller what to do at which time and which instruction to execute at any particular time. So this is the one way of this way that kariRS ensures non-blocking manner of writing code. So most of the time, if you are writing non-blocking code, you'll be using kariAsync. And it is very flexible. You can write it as a function, like you can see how it is written. Now, for those of you who we were last time, this is a trick that you might not see in the documentation currently, but I'll show you this. Since kariAsync is a macro, you can do something like this. You can use these kind of braces to can also use kari braces and cross it like that. So basically you can use that style. So that's something you can do. You can also use that style. You can also use the square brackets. kariAsync will be okay with that. Okay, but the most of the time you'll see me using this kind of braces because they look nice. That's about preference, but again, kariAsync will be it will have no issue with that. And same goes with things like kariRS sequential, calipers, and all the rest of the macros. They will also agree for you to do that. Just make sure you stick to one pattern so that you can have a nice code or code that is easier to read. Because again, kariRS is not just about performance; it's also about code readability. So again, I'm going to compile this code so that we can see what happens when we run this piece of code. And again, this is a scope of what we were doing previously, so you can check out on last time code. So I'll head up to the terminal. Those who are new to the terminal, you can watch the previous sessions and you'll be able to catch up. So it was intro session 2. Let's check. So we need yeah, so clearly we're there. So I'm going to connect the microcontroller. So I want to show you the microcontroller that I'm using. So that I'm using a Mega 2560. Even for the rest of the, let me can, don't know whether you can see the MCU that I'm showing. Yes, this is a microcontroller that we'll be using. This is a Mega 2560. So it's the one that we'll be using for this session and for programming as we continue. So you can use Uno, you can use Nano. Any AVL board is currently supported by the kariRS framework. So basically, you can use any board you want. And as we continue, I'll be showing you kariRS best practices in order you can be able to ensure that you use the best of your memory in your microcontrollers. So with that said, so I'll go ahead and upload our code. So literally, since I'm not aware of the port, remember when you connect any peripheral to a computer, it is assigned a port, but I do not know the ports in which the MCU is connected to. And literally you would not know. So carry helps you to do that. So we kariRS. So I told you that kariRS has got two commands. It has got carry, or you can use kariRS. So the shortest is carry. So I use carry detect like that. And even if I wrote kariRS detect, it's the same thing. So I can already see that my microcontroller is connected to COM number 11 as a port COM 11. So that is what I'll be using. So I can use carry. Now we have, I can do carry upload. Now here there's something that we've not mentioned so far, and I've not mentioned it for a reason, but for this far I think it's also good to know. So the moment you are learning carry upload function, you have to give the port via P. This is what we've been doing. But kariRS is forgiving if your computer is connected to, for example, just one microcontroller. You can just you can just let kariRS decide where the port is. It can search for the microcontrollers in the computer and it will upload to it, because it first checks whether that's the verified microcontroller and whether it aligns with what the configuration says, and it will upload to that microcontroller. Now if you have a lot, it could be a bit confusing, but since we have one, we can try and do this, and you will see that it will build the project. It's currently building, and you can see it has uploaded to the correct MCU. Literally, you can already see this is at Mega 2560. So it's the same as writing what we have been doing, writing carry flash P, then you give the COM. For us, it's COM 11. It's the same thing, but you can also write carry flash without giving the port. literally, most of the time I'll advise you do this if it's only one MCU connected to your machine. If there's multiple MCUs, then you might be wondering which MCU got the code. So this is something to be very careful. But again, if you have just one MCU, of which most of the time you'll be connecting to one MCU, that is the case. But we'll also be seeing other tools. You have other tools in the carrier ecosystem that allow you to do even multiple flashing. We'll be looking to them in as time goes by. So now we've already uploaded the code. So I'll connect some LEDs to these pins 24, 25, 26, and already we can already predict what will be happening, or we can already predict what we should expect. We should expect that pin number 24 should be high at one point in time, and after 200 milliseconds, as specified by our scheduler, we should see pin number 25 go high while all others are low, and we then go and get pin number 26. So when you do that, you have already been able to design a LED chaser circuit. For example, this is basically an implementation of LED chaser circuit in kariRS without blocking the code. So it means you can have an LED chaser circuit in your microcontroller without blocking any other thing that is going on in your microcontroller. You can be reading sensor data, you can be sending data via Bluetooth or anything. At the same time, when kariRS is also blinking LEDs or doing such kind of things, which traditionally, as we have seen, we used to use delays, and that would cause blocking nature of other tasks. So this is how kariRS enables scheduling in single core MCUs. So let me connect this, and then I show you the output. So we have pin number 24. Connect pin number 24. Let me do the connection. And 24, 25, and 26, literally. Um, we did upload the code, but I need when you are muted this, we do not save the file. You need to save the file, but they always remember to save the file. So we uploaded the last time's code. So I'll be very fast to do the uploading. Always remember to save your code once you have updated anything. So now let me show you what's going on. So literally, this is what we have. So I don't know whether you can see clearly, but this is what we have. We have these LEDs. I think it is too fast for people to see how the sequence is working. So we go to the code. You can see my screen. So we can make it for 1 second. That's 1,000 milliseconds. So I do that, and then I'll save the file, and I'll upload the code again, literally. So it's uploading the code. So let's just wait for it to upload, and literally you see its speed go down. Yeah, so you can see those LEDs. I don't know whether the camera takes them clearly, but as you can see each is on at a time. So it's an LED chaser. When you increase the speed, you see it's an LED chaser. You can add as many LEDs as you want. But you can see this is how kariRS manages the state. Now, if you are to try to write this algorithm by yourself, literally you'll be doing a lot of work. So you can usually use carry sequential to do this. So this algorithm is implemented by you natively, so you don't have to install any external library. So this is all about carry sequential. So if you have any question about the timing basics, you'll mention them in the group and or in the Discord server. If you are in the kariRS Discord server, you can mention your issues there, and I'll be able to help you out. So this is all about carry sequential. So is there anyone who has a question about it before we engage into the serial communication? Anyone who has a question about it? Yes, anyone who has a question about what I've just mentioned about, or anyone who had a question about the timing basics of carry sequential? How many here it's the first time they are meeting kariRS? It's your first time to hear about kariRS or to even interact with it. So everyone is uh, okay. Daniel. Okay, Daniel. All right. So Daniel, are very much welcome. And I think because of that, let me share with you the link to the GitHub repo. But again, Daniel, have you interacted with something like Arduino? Have you coded in Arduino before? Because it's something that could help you relate. Have you coded in Arduino before, or you are completely new in microcontroller programming? Daniel, you can unmute your mic and reply. Okay, all right, completely new. Okay, but again, you're in the right place. So you're learning kariRS. You're also learning it together. Uh, we've not done many sessions, so this is our third one. And again, kariRS is a good. It's a good thing to engage in. It will teach you a lot. So I also see Dolphin, Daniel, and are you two people in the kariRS WhatsApp group? Uh, if you're not, I would very much recommend that you join the group, because there, if you have any question, I can personally answer to you, or if there is any issue, you have a project with kariRS and there's any issue, I'll help you out. Now back to what kariRS is. So just to mention for you, kariRS is an embedded framework that is based on the Rust programming language, and is what we are literally exploring to make our codes better and to learn more robust programs. You can watch our previous sessions and you'll be able to learn more, visit the documentation, and all this will help you a lot. Something else I wanted to mention today, I want to mention a couple of things, because again, when we come to serial UART communication, that won't take much. It won't take much of our time, because it is something that you'll be able to finish very fast. So I'll be also showing you some other things in kariRS so that we can make sure we make the best of it. So now in my screen here, I also wanted to mention about Docker, about kariRS Docker, just for a minute. Alright, so you can see my screen. So recently we've launched this one. This is a official kariRS image, Docker image. So if you are a person who is, you are a server side guy, you are the person who likes doing their stuff on the cloud, or learning their own environment, you don't want to do all these configurations we've been doing for kariRS. Now this is for you. This is a kariRS Docker image, and if you're a DevOps engineer, or you're a person who looks into exploring embedded into in the cloud, or doing stuff like this is for you. kariRS is now available for use in the cloud space. So for the kariRS Docker image, I want to be clear on what it does, so you don't wonder what it is actually. So actually, it is just a pre-configured environment. For us, we have been installing kariRS, and we have had to install kariRS, and we have had to tell kariRS to install its dependencies and all that. But here you don't have to do that. kariRS comes in pre-installed with all its dependencies, with all its tooling. You just download the environment and you use it in your containers. You just learn Docker as you just learn kariRS as a container. So basically that is it. Now the other thing I wanted to mention, and that's why I've mentioned about here, is that when you're learning this one, in for example in the server, if you're learning kariRS in the server, you won't be able to upload code to your MCUs. So don't go trying to do kari upload, kari flash. No, don't try that, because your MCU is connected to your phone, is connected to your laptop, but now you're learning kariRS in the server. So basically you have no access to hardware. So then you might ask, why do we have kariRS Docker image? So what it does, it helps you to test code. You can write code in the server, or you can write code in the server without having to download stuff like kariRS, test your code and do all that. You can be able to generate hex files. Remember, when you compile your codes in AVR, you get hex files, and then you can download those hex files and you can then upload them to your MCUs. You can do that. But also we have another way. If you have Docker in your laptop, you can always be able to access hardware, and that has been covered here. Accessing hardware devices from in kariRS via Docker. So if you're a person who does Docker or is exploring this technology and all, you don't even know you could explore it, but now from an embedded point through kariRS. So that is something you can check as well. So now let's dive into what uh, into today's topic, which is about serial communication. But again, I would open, if there's anyone who has a question about what I have mentioned. Uh, don't feel don't feel like I've closed on you. You can ask any question so far. If you have any question or anything you would like to mention, anyone with a question or any insights that they want to ask about. Yes, anyone with a question so far? All right. Okay, so then we will dive into serial communication. So today we'll be dealing with UART, that is universal asynchronous receiving and transmission transmission. So this is not something that is new. It's just that we are just wanting to speak about it in kariRS. If you want to something like Google here, and maybe you type something like UART protocol, like that, you search to what it is, you can already see it well defined here. You can see the universal Asynchronous receiver transmitter is a protocol used for serial communication, and it allows data to be transmitted and received without the need of for a clock signal, making it asynchronous. UART is widely used in microcontrollers, and that's what this is what we are doing today. It is widely used in microcontrollers and other embedded systems for communication between devices. Okay, so that's what we are doing. But now in kariRS, we want to see how can we do it in kariRS. So back to our code. So I'll clear all this, or maybe we can just build a new project instead of sticking with this old code. It will also be good. So that's oh, okay, I'm not sharing my entire screen. Sorry, let me share my entire screen. Everyone can see my screen. When I'm sharing my entire screen, I cannot be able to see symbols or anything. You have to unmute your mic to reply to me. Can you see my screen clearly?
Yeah, we're good.
Okay, thank you. So I'm saying, instead of using this file, I think we can create a new project to also help those ones who are new to see how we do create a new project. So I'll go back to the terminal. So I just create a new project, carry new. I'm using the mega board, so I'll pass in mega. So today we are dealing with serial UART. Maybe you can call it serial UART like that. And we already have our project, so I can cd into serial and open it in VS Code. So also, if you have a question, you've not understood how we do create a kariRS new project, you can ask. But again, the first session recording has all this, so you can always review it and you get so now there's a trust almost. So we are done with this, so you can close this. You can also close that. Yes, so now you'll be so that's how you see how it's easy to create a new kariRS project. It's just very easy, very easy. You just type in this command, carry new, and actually I can show you if you forget what a certain command requires. If you want to know what a certain command what are the parameters it requires, you just type carry. That's the main command. And maybe you wanted to use a new command but you do not know the parameters it requires, you just use hyphen help like that. And if you click enter, it will basically show you how that command is used. For example, here it is showing you that it takes an argument of name. Name is this argument we have given here. Anything that appears here, it is just telling you that that one you just pass by name. Then it shows you the options that it takes. It shows you the hyphen board or hyphen board, which is what we have passed here as mega. So that is how you, for example, if you forgot how to use curly flash, you do not know how to use it, you just do hyphen help like that, and it shows you all the available options. You can see it has various options. I'm sure you have not used some of these other options, but again you can try on them and see what they mean. If you have totally forgotten or you do not know about the carry command, you can just do carry hyphen help, and it will show you all the available commands. You can see we have a lot of commands. We have new, flash, upload, monitor, build, doctor, detect, update, add, remove. Some of them I know you have not used them, but again we'll be seeing what they really mean and how they are used. So back to the code. We want to deal with the serial monitor. So basically be putting into the serial monitor. Uh, so the first thing you do is to initialize the serial monitor. You want to initialize serial communication, you have to tell the microcontroller that you want to do it. You have to initialize the peripherals for the serial communication. And in kariRS, we use a macro which is known as serial. I want to take you to the documentation, so I show you that it's already there. So this one is what we use. We call it serial. And once you call it, you have to give it the boundlet. The boundlet is the rate in which shall be used for the communication. So you see that says this one initializes over the default UART, and it takes about sorry for how is it? It takes a boundlet which is a U32. So we have an example. So U32 just means it is an unsigned integer of 32 bits. So do not try to pass a negative digit in here, kindly. That one will not compile or what will not work. So this is an example with the most used baud which is 9600, but some boards also support 115,200. So you just test and check the board you are using which kind of bound rate it supports. So that is about the serial. So we'll be doing that. Then from the serial we have a function known as printing. Now this is what we'll be using to print into. This is what we'll be using to send data over the serial communication. So most of the time, if you've seen this function, you might think it is just for printing, and you'll be true to do that. To take that, it is true to agree that yes, this key printing is used for printing to the serial monitor. But again, we'll be seeing that it is more of just printing. So then there's this print. It's print formatted output over serial. So works like class printing and all that. And you have been given an example of how you can use it here. So this is all which what that the documentation gives us about serial. But I want us to see more deeper into just what these few lines can expand into. So let's start with initializing uh, our peripherals for serial communication. So we'll initialize it like that, serial, and we'll be using 9600. Basically, Mega supports this one to communicate, but again, you can try various values. But we have those supported values. You also have 115, 200, but most of the time, Mega Uno they will work with 9600. So I just go with 9600. So now after that, after doing this initialization, now it's when you can be able to communicate or to print to the or to print to your monitor. So I can be able to say inside of here I can write k printing like that. I can be able to say hello world. So you can see if I write like this, if I was to compile this program, it should just print hello world into my serial monitor. So that is what I want us to do first before we even go to anything else. So I will save this program like that. And I want to show you some few tricks about serial communication. It's actually easier than what we were doing last time. So for example, you've been seeing me coming back to the terminal here to do the compilation, but if you're in VS Code, you can just access the terminal by pressing Control and then this sign as request, the tilde sign, yeah, that button with a tick or the tilde sign. So you can press Control and tilde and you can do this, or you can just come here and click the terminal and open a new terminal. So that is how you do. So I can just come here and run carry upload like that. So you can see already, even without giving it the port, it knows that it will. So first it is building, let it build so that it can upload. I already made it clear to you that the upload button or the upload command for that matter It is used when you want to build and upload the code. So you are sure the code is correct. So even if you're not sure, you can still use it. But most of the time you want to first build the code and then flash it. But if you're sure it was just a minor tweaks you're doing in your code, or you're sure it will just work out, you can just run kali upload. Now, again, there's something I want to mention to those ones who are new. You can see that our program here is compiling, and you can realize that it is taking more time than what we were than our previous project. Now, the first time you create a new kariRS project, it has uh, it has some dependency for your project that it has to compile for the first time. Now, all those binaries which uh, uh, which are tied to your project are being compiled for the first time. They will take more time. So the first build in kariRS will always take more time, but the consecutive builds are always fast. So that is something to take note on. But this is in kariRS version 1.0, and we'll be seeing more improvement in the next versions. But again, this though the first build is takes more time, you realize it is not that so long. So let's wait for it to let it for it to actually compile. And this is what makes it the consecutive compilation faster, because the consecutive compilations will just rely on the cached builds of the project dependencies. So only your files will be compiled. And again, this is also useful because if there is any library with kariRS, it will be compiled once. This is something you have seen with things like platform IO. It does that. It does uh, compile and then it caches. Same thing you have seen here. So let's wait for it to finish. Uh, and so up to this point, let me show you something. So all these are the dependencies that are first compiled, that kariRS first compiles, so that you never have to compile them again. It's like compiling even the things you won't need for your project, but if you need them at the point you need them, actually they will be there for your usage as fast as possible. So now it's compiling our code right now. Is there someone who wants to join us? Yeah, someone wants to join us. Yeah, Wesley, you are welcome. So currently these things you see warnings, just ignore them for now. They are just I mentioned it due to the fact that kariRS is still in development, so just ignore them. They are just kariRS warnings. They have nothing to do with your code or what you're doing. So you can literally say that the first build takes a bit of time, but you'll compare that with the speed that in which it will build for the second time. So already it has already uploaded our program. So let's see what we'll see in our monitor. So to open the monitor, we do kariMonitor. Now, if you wanted to see the all options available for this command, you can also do --help like that. And you can see it requires the port, and you can also give it the boundlet in which it will communicate with your with your microcontroller. Now, let's try to not give it the port and so you see what it says. It says you failed. You need to specify port in CLI command. So the kariMonitor is not forgiving. It's not. It doesn't implement what you see in uh, in upload or flash when you have one MCU, and it has been done that intentionally, because if you have so many MCUs, it will be a bit of an issue. So you have to specify on which port you want to open. So we will say we want to use our port COM11, which is where we have connected our MCU. But now I want you to notice something. Right now we don't see anything printed, but we already wrote in our code that it needs to print hello world. So we don't see anything printed. So we want to ask ourselves what is really happening. And now this comes because there is a mismatch in the baud rates. This here we are saying we are using 9600, but we did not give a baud rate to kariMonitor. So it is using 115,200 as the baud rate. So because those baud rates are mismatching, that's why you don't see anything. And sometimes you might see just garbage characters being printed here. So let's try to end that and try to see whether we can solve that. Let's try to see what will happen if we give it the correct baud rate. We give it the baud rate 9600, which matches what we wrote in our code. So the moment we did that, it printed hello world. So literally that's how you deal with serial communication. So let me repeat that one again. So if you've not gotten it, you can. So to exit from the monitor, you can just press Ctrl C to just kill the process, so we can clear. Now I said if we run kariMonitor with the port, which is our port here, if we just run it without giving it the baud rate, it default to using the default baud rate is 115,200, but this default baud rate does not match what our code says. Our code says that the MCU has been initialized to use the baud rate 9600. But what do we see? We have not the baud rate that the kariMonitor is trying to communicate to our MCU is different. So we will basically either see garbage or nothing will be printed. So that's why we can see nothing. So I'll press Ctrl C to kill the process. Like that. And that's why I said you need to now write kariMonitor and you give it the port, and then you give it the baud rate, which for us we chose to use 9600. Now if your baud rate was 115,200, you not even need to give the baud rate, but because we are using a different one, we need to give it. So we can give it like that, and literally we see hello world, which is what we wrote in our code. So basically that is what you that is what you do with you do to print things in the serial monitor. But then a question arises when writing real embedded code. You won't be typing things like real hello world. You'll be creating variables, we'll be updating data from the sensor, and probably let's see how we can maybe print data from a sensor or something. So we'll assume we have connected a sensor. We are not we have not hardware connected a sensor, but we'll simulate that here. But if you connect a sensor, it's the same thing. So for example, I can say let mute. I can say maybe let's have a counter, a value counter, and call it 0. Sorry, don't worry, those are just suggestions from the VS Code. So we have a variable known as counter, which we'll call 0. Now, if you are new to Rust, to the Rust programming language, you realize there's this keyword known as mute. Mute means mutable. Because I will be changing this value, I need to tell the Rust programming language that it will be a mutable value. If I did not give it that, it will be a constant in or an immutable variable. In Rust, everything is a constant. Unlike other languages where you can you can modify things unless you make them a constant. In Rust programming, things are the other way around. So I'll make it mutable like that one. So now, okay, I'll just leave this one here, but I want to be incrementing our value. I want to do this one asynchronously. By now you've known about how to schedule, so we won't be using these tabs of like delaying or whatever. By now, we'll just use the high-end APIs for kariRS, the recommended way. So I'll create a task, and this task we run every 1 second, and I call it task 1, like that. And yeah, literally like that. So you can see I'm already getting suggestions from the VS Code, so I can just do that. So what is our program doing? So it's counter. We are incrementing the counter by 1, and then we are printing it like this. So let's save this file and see and compile it. So again, I need to mention something. You can see right now our monitor is connected to our MCU. So it is currently the one in charge of the serial communication. Now, if I try to upload the code, like carry upload, let it first build. Let's wait for it to reach the uploading stage. It will basically fail. So you can see from here, program flashing failed. Unable to open port 11 for programmer wiring. It cannot. And that is because when you are uploading code, you usually use the serial communication. Like it uses the TX and RX. TX is for transmission, RX is for receiving. I'll be showing you that one shortly. But again, you need to ensure that before you upload your code, you need to make sure that you close the monitor. So I'll press Ctrl C to kill the process, like that. So after killing the process, I can just do carry flash because we have already built it. So it just needs uploading. So then I can clear and we can observe our monitor. So we can see counter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can clearly see that it is incrementing just like we wrote in our code. After each 1000 milliseconds, which is 1 second, it is incrementing the counter and then it is printing the result. So basically you can see that is what we have here. That is what is happening. So assume it is a sensor data or something. This is how you would actually print it if you wanted to be to show it here. This is one of the things you can do, though I want to be showing you some more things. So this is how you can do the printing. So let me kill the process because we'll be uploading a new code. Let me kill the process here. So now the other thing is actually let's even get rid of this counter. Yeah, let's get rid of this counter and let's try something else. Let's try reading a port. Let's try reading one of the pins in our in our MCU. we know it's not connected to anything, so it will have a bit of noise. So because we want to read that noise, so we'll do analog read. Let's maybe say, which port can we read? Maybe we can say analog read 0, like that. So if you want to do something like this, literally you you have to have ensured that you have initialized that pin. So basically we've been doing something like pin mode, and because it is an analog pin, for analog, analog pins can only be input, and we add an underscore in front to mean that it is analog input. This is how we do stuff in kariRS. I know in things like if you're coming from Arduino, you are only used to outputs and inputs. But in kariRS, you have to be explicit. You have to tell kariRS what kind of input are you talking about, what kind of output are you talking about. So basically, that's what we do. We usually have 4 modes. Now, if you have forgotten, or for the sake of those who are probably new, for pin mode, can initialize your pin as a PWM. You have to ensure it supports PWM, because if you give the wrong PWM pin, the good thing with kariRS is that it does not close an eye on you. We've seen things that Arduino closes an eye on you. You can tell it you can give it a pin that is not PWM, and it will just keep quiet. It won't tell you anything. But kariRS is very strict. It already knows the pins which are PWM. So you can always give PWM. You can give input, that is the digital input. You can give output, and you can give what we have given here, input. Those are the 4 states that are supported by kariRS. PWM is an output. It is what we call, it's like an analog output, but it is the pulse width modulated output. And then this one is the digital output, and this is the analog input. So basically, those are the 4 states supported by the pin mode. But I don't want us to use the pin mode. Literally, I don't want us to use the pin mode. So I want to show you something else that we can use for initializing pins, and that is, I want to show you where it is in the documentation. So if you ever need it, I know we've not yet talked about this, but or if you maybe you've just seen it, me write it. So we have carry begin. So this API, it is used for bulk that does what we call bulk configures multiple pins with the same mode in one call. What do we mean by this? So we means it takes a pin array and you give it the one of output mode. You give it a mode. So for example, you can see in the documentation it has shown you an example. You can give it an array of pins and tell it the mode you want. You can give it an array of pins and tell it the mode you want. That's what I want us to do. Though we have just one pin, and maybe it might sound okay redundant for now, but it will help you to learn something new about kariRS. Today we are not just learning about serial. Serial is something we can. It's a very fast thing. So we have, you can light it as literally you can light carry. You can see I already have. So carry begin, you give it the array and you tell it the mode. For example, for us, we are using that mode. The we are using the the analog input mode, which is underscore input. So here is where you pass your pins. So for example, you have 0, 1, 2, 3. All of these would be initialized as analog inputs. So let's just use 2. Although we'll just use 1, literally it's just for the sake of showing you what is possible. So now kariRS won't fight me if I do this. So I'll save this and let's see what happens. So let's upload that. Let's carry upload. I hope I've saved that program. Yes, let's so literally let's enter the monitor. And so what we are basically showing are the noise values from the analog input pin A0 in the mega. If it was the Uno, it's still A0. They are named the same. So the pin is floating. It's not connected to anything. So you can see the values we are getting are just noise values here. So that is what we are just basically printing via this statement. After each 1 second, that is what we are printing. So literally that's all about the printing. Now I think we have already mentioned about printing and all that, but then the question comes, I mean, uh, what I already mentioned to you, that K printing is not just for, like, it's not like for uh, printing stuff on the serial monitor. It's more of that. Now we have this module Bluetooth. I want to give you, for example, which is known as HC. We have this HC05 or 06, any the Bluetooth module. We know of that Bluetooth module. This Bluetooth module uses the serial communication. It uses the UART serial communication. Now, if we had connected it, currently I don't have it with me here. So if you could have connected it to your microcontroller, you would connect it to the TX and RX pins, which are the channels we use for the serial communication. So TX is for transmission and RX is for reception. Now what we have been looking at currently is what we call TX, and TX is just, now this K printing you are using to print is the same that will do what we call TX in kariRS. Basically that's how it works. So this, if you were to, if I was to like go to where the implementation of this function, if I went to the implementation of how it has been implemented, uh, this is the K printing. I'd basically show you that it taps to this object here known as kariSerial, and okay, this one won't show us well. Let me show you how we can visualize it. But if we go to serial itself, how it has been implemented. So yes, if we go to now here, how we implemented it, you can see now inside of serial we have this object known as kariSerial, and this object is then split. We have split it into RX and kariSerial. So this kariSerial, we could have named it any other name. I just decided to name it kariSerial, basically for, no, that's just a preference for me, but basically you never need to deal with this. This is just the internal implementation of kariRS. So this part is what we call the TX. So you basically see that K printing is the TX. And now we want to look at the RX. Where is the RX coming in? And I want to show you that this is the RX. Now this is something that okay, currently don't mention it in the documentation, but it will be there very soon. So but I'll be showing you in this session how to do the RX. So we use this object here that is defined known as the kariSerial listener. So let's just not come out of the implementation, and let me just explain it to you in simple terms. So this is the TX, the transmission. This is what we are lighting here when we are printing stuff in the serial monitor, that is doing actual transmission. If you are connecting another microcontroller or something that was to be that was communicating via UART. Each moment you printed hello world, that hello world would be sent to that device if the TX of your microcontroller is connected to the RX of the other microcontroller. So that is how UART kind of works. Now, whatever we have done so far is we have been looking at the TX side, but most of the time, if you are doing like if you are not just dealing with the screen or just printing stuff or debugging, so TX is mostly for debugging, and RX, most of the time we're communicating with most modules. You find yourself using RX. For example, if you're using your microcontroller as a slave, you are connecting it with the HC05, you are using your Bluetooth app to communicate to the microcontroller to control it from your phone app, then you want to tap to the RX. And this is what you want to see. How do you tap to that in kariRS? You want to tap to the RX. So because I told you I do not have a HC05 or a Bluetooth module that I can be showing you with it, but I'll show you how to use the RX in another way. Now think of it this way. For example, RX also comes into play if right now, let me switch on the monitor again. Right now, the monitor is giving me values, but what if I wanted instead of hard coding the values that are to be printed here, what if I wanted to just like type them in the I type them here in the serial monitor, and then the microcontroller processes them and prints them back. If right now if I typed something like, let me say carry, oops, remember it's still typing, so I have to be fast. But you see, if I try typing anything, okay, it seems confusing. Let's first comment out this and we save our program, and let's just upload that one. So I've gotten rid of this task so that it can stop uh, disturbing us, so that we can understand about the RX part of the serial communication in kariRS. You see all these things, these warnings, just ignore them, ignore them. They will have gone before you notice. They are just there because kariRS is still in development and is in continuous improvement. So let's say, okay, now let's now open our monitor and we see hello world. Now, what if I wanted to print something to the I want to send something to the microcontroller. Now, I could simulate that by maybe typing king, but you see nothing happens. I just typed it, but the microcontroller does nothing. It knows nothing. So, I want that if I type, that my microcontroller can be able to show me, yeah, you know what, I did actually see something, yeah, I did actually see something. So I want my microcontroller to be able to receive, and that is the RX part. Yeah, that's the RX part. So I want us to tap into that one. So we'll just, so that's where we'll tap into carry. As I showed you, we'll be tapping into this object known as carry serial, and I showed you that it comes from serial. We have this K pretrain is the TX, and if you check out the serial like this, so this is where it comes from. It's really good if the moment I take you through things like this, it's very easy. If, for example, you're also looking forward to be part of building kariRS um, as maybe a library developer or something, it's very easy to understand even how to navigate through looking at the implementation of how kariRS itself has been designed. So basically, this is the main interface, and then we split it here. And after splitting it here, we we created this object, and this object we can go further. Okay, not the VS Code is not allowing for continuous, but this class here is what deals with this kariRS. It is what has been done for you here and provided as an instance. You have been given an object which has already been initialized. So you'll never find yourself creating something like this. So you just need to remember there's something known as kari serial listener, like that. That's how we type it. And then this object has a method known as listen. You can see VS Code already can be able to already tell, because VS Code and kariRS, it's able to integrate very well. So I can just press on tab and we see that. So what does this one mean? So this kari serial listener is like it's an object instance of what we call a serial listener of the RX part of the or in kariRS of the UART communication, and it takes in a function which is a closure which takes in a parameter of data. The data is whatever you'll be sending or receiving from your sensors or from your build or from other UART serial communication devices which are communicating in your RX. Whatever data they send, it will be passed here into your function. So you cannot just type you cannot just do this. You cannot just come and create a closure or a function like that. This one is very long. This one won't compile. You have to give it data like that one, and you can even tell it the type. Maybe it's a string, blah blah blah. But if you are not sure of which I recommend, because most of the time you don't know what will be sent from other devices, just leave it to be that. Let's kariRS determine what is going on. So now I think we can just go with this recommendation that VS Code tries to tell us. It's trying to tell us, oh, do this, do this. So we can type this one. We want that whenever I print data, we say received data and we interpolate that one in this message. Whenever in, if you're wondering what are these inside of this string, this is what we call string interpolation. So this is how, so kprinting is that powerful. You can be able to do string interpolation. So let's save this program and upload it and see whether our MCU will be able to respond, because right now it's not responding. It doesn't know how to respond when we type things. So let's upload. Uh, 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 let's see whether we can move a bit also faster so that we can finish on this. So let's clear and let's open the monitor. So right now we can try to write let's say not let's say RX in kariRS, like that. RX in kariRS, say enter. You can see it. It is printf receive data RX in kariRS. Now this is what I have written here. RX in kariRS is what gets passed into this function as data. It is this data. Okay, so this RX in kariRS is this what we see here, data. Okay, and so when I say I want to print to the serial, now I'm using the TX part. I want, but now send it to the monitor. What I will do is that I'm interpolating this data into this string. So that's why you see now it print back and say receive data RX in kariRS. So it's like I'm doing this, I'm sending data to the microcontroller. The microcontroller processes it and sends it back to the screen. So literally that is what we are doing. So I have done RX and TX at the same time. But that's how RX works. You can also have connected in your now in your peripheral, in your microcontroller, you will always find a place where it's written TX and RX. Now, that point known as RX, if there was a module that communicates via UART, whatever it would be sending via RX can be tapped from this listener. You can see this listener, and the recommendation of this listener, please kindly do not put it in things like kariRS. This one, you leave it alone, you leave it in the loop. It lives by itself. Its work is to listen to data. You don't want it to be caved by the things like the scheduler. Never put this one, never do something like this. Let me show you by typing, because my and you're not getting it by talking. Never do something like this. Now you come and put the listener here. Okay, it's not like the code would learn, yes, but now think of it this way. When you put this listener, the serial listener of the protocol, if you put it here in the scheduler, and you know that this scheduler operates after each 1 second, or even worse, maybe you have even written 3 seconds, then it means this your listener will miss various data. It won't be listening continuously as is expected. You'll be killing its purpose. It's better you do something like this. It's better you have the scheduler inside of the listener, if at all you have to have it. But again, the good practice is you would create a variable here. Maybe you could create a variable here if you know the kind of data you'll be receiving. Let's say it's numbers, or it is a string. If it is a string, yeah, you could have something like a mutable data here, and each time you receive new data, let's say this is, let's differentiate it and say this is let's just call it dat for data, and maybe you could be saying that is equivalent to data, like that one. And maybe now here you can come and create a scheduler which can then manipulate that data. That is a much more cleaner code, or more cleaner workflow. So now let's continue with what yep, I think we can, yeah, like that. So now this is received data. So if I was to print anything here like king, we get the received data king, like that. So basically that's what you can do. This is the portion that is not listed here in the documentation. Literally, I just realized that. But again, that's why we also have these sessions to elaborate much more further on kariRS. So you can see there's a lot in kariRS, and a lot is going on. So this is basically how you design, or you use the serial listener in kariRS. So far, is there anyone with a question? I'm trying to move faster so we can cover everything and wind up. Is there anyone with a question so far about the serial listener, or about anything about this serial communication in kariRS? If you have a question, unmute, because I might not. Oh, okay.
Yeah, thanks, Vincent. I don't think there's many of us left. It's only myself and Daniel.
Oh, okay. I've just realized that I've not been looking at the screen. Okay. Oh, okay. Thank you for staying. Now the meeting has been so long. I've taken a lot of time.
No, I'm okay. The others were brand new, weren't they? They probably got lost.
Okay. Then let me try to wind up then. But I'll try just to make sure we cover what is needed. And if you don't understand anything, you can usually go back to the recording. It's usually better to attend the real meetings, because you can ask questions there and you can get clarification of even things you never knew about. So now we've seen how this carry serial listener works actually. So there's something I think I need to mention about the printing, which was something that was a bit take it for granted. If you are coming from Arduino, we can take it for granted, but I think I need to mention it first and then we can wind up. I hope you are good with this serial listener. So I'll just come back here and unmute this. Now I want to try and get rid of analog grid.
One question while I'm thinking. Sorry, Vincent.
Yes.
Just thinking. The data only comes through after you enter. It doesn't come through on data. It just seems to. It only comes when you press enter.
Yes, it comes when you press enter. When you send it, when you press enter, you are sending it through.
Okay, so if it's machine to machine, you'll have to put the carriage return at the end to transfer.
No, when it is machine to machine,
Yeah.
there's no issue. The reason the reason I'm pressing enter, can you hear
Yeah.
me? That is just that is just the design for carry monitor. That's just how I had designed carry monitor to be. So it waits for you print whatever you want and then you press enter. That was just to this just a way to show you how RX works when I do not have a machine to machine thing. But from machine to machine thing, everything will work
Otherwise,
directly.
you get double. Otherwise, you'll be getting double characters as it pushes it out the monitor at the same time.
Exactly.
Yeah.
You got it.
Yeah.
Yeah, okay. Yes.
All right.
Okay. You're welcome. So now let's meet. There's something we usually take for granted that I want to show you. Let me try this. Instead of now, you've seen we've been printing uh, strings and numbers. Let me try something. Let me try printing something like 789.98765.4. Now that one is, what do we call it? That's a float, right? Let me just try that. So bear with me. We do that and then we can wind up the session. So thank you for you guys still keeping up. Actually, maybe I had not noticed people have slipped away. So now, do you see something? Okay. Oh, we've not. Okay, let's upload the code. Okay. Okay. And actually, you're seeing something. Actually, this code should not compile, but let's see. Maybe, maybe it will compile or not. Maybe. So it okay. The code was uploaded because there was already a sketch. It has uploaded the code that was already there, but we see this error, which is very important. This is something we take for granted. So you see, it tells us you display is not satisfied and all that. You see, when designing kariRS, this was a major issue of how do you even print such, how do you print floats to the screen? How do you send these ones via the, how do you send these float characters via the serial communicator? You see now in Rust to do that is a bit of workarounds. So there was a lot of this issue, and that is what I wanted to raise out for you, because I might show you this. We are sending strings, we are sending anything we want, but when it comes to just sending a float by itself like this, kariRS will really it will indeed very much be, it will indeed be in trouble. It can't do that unless maybe you try to do something like this, then do make this one a string of which doesn't even make sense. Yeah, it's right. Even if you were to say like this, even if you are to make it a variable somewhere and try to put it here, it would be an issue. Actually, let me try it so you might not think, oh, he's just saying it. So let's say let's float data be equivalent to any number 876.453. Any number is okay. So this is okay, float data. So this is the float data. So let's see whether there's any issue. Let's save the code. Let's see whether the error goes away. and literally you can see the error never went away. We don't even need to go to the compilation. VS Code and kariRS are integrated, they integrate well, so it will just tell me. So it tells me that the UDisplay is not satisfied. So basically the design of K printing, it cannot be able to process it uses something known as core, which is part of Rust. I won't get into those deep implementation of what we've done here, but the thing is, it can't deal with float integers. So to do that, in kariRS, we came up with another workaround, which I will show you very fast here. The documentation. Let's check. Let's see. Uh, if it's not there, if it's not mentioned, then we'll add it next time. Let me go up, 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 up to here. So we have advanced macros. That is part of the core macros. So you literally see it's not mentioned. The same with the thing we had, like the kariRS serial listener. So literally you can see this the importance of having these sessions. But again, we will find them very much into the in the in the documentation very soon, very as soon as possible. So now let's try to see how we can do that. How can we print float inside, or how can we send floats? How can we transmit float numbers inside of kariRS? So for that one, we will create what we call, we will create another float data, let's call it string. And here we will create something known as carry string. Carry string is a function in, or it is a string class in kariRS. Now, because in embedded system we have no access to the standard library of Rust, which is what enables people to be able to type things like these floats. In languages like C and C++, there's no issue with that, but in Rust, it's a big issue. So I had to come up with a workaround around this. So you have this class known as carry string in kariRS, which you literally do like this. Now it's kind of a weird syntax, but don't worry, bear with me. I'll be explaining what is happening. So we create something like that. So here we can say 0, maybe. We can initialize it with 0, because again, if I initialize it with float data, and maybe you are using something like, I'll be showing you a project I was working today, and this was a main issue I discovered. I found out with the nano. Now, if your memory is so much constrained, doing this would be so heavy for your microcontroller. For here, we can give it 16. So here we are just telling it the number of characters that it can take. So instead of, I would advise you, instead, if you are going to be creating a carry string, to use it with a float. Don't initialize it with that float. Just initialize it with a 0. That way it will be much more lighter for your microcontroller. Even if you are using Mega, that's not an issue. But for things like Nano, that's very critical. Now, let me first show you what carry string is very fast. So you can see it is a struct by itself, is just calling it a class, basically struct, or you can, the way you have implemented, you can just call it a class. Now you can see it has this new function and all this, and it takes in a data of type T, it returns self, and all this kind of stuff. So this is how you literally get to build a string. So n is a usize. You can see it here. It just says you just tell this function the number of characters your string will be. So this carry string, we will initialize it with a 0 like this. So basically it will take this 0 and convert it into a string. So this is like converting strings. Now instead of here typing data like this, we will do float data string, like remove this and it's called format float. Literally, this is what we will do. I know it sounds a bit verbose. Oh, not in here, sorry, but in here. Now it kind of sounds verbose, so quite verbose. Now we can see I get an error which tells me that this method takes 2 arguments, and that is true. You need to tell this carry string how the number of decimal point you want. So for example, for us, I can tell it we want just 3, like that one. So if I tell it 3, this is what will happen. We have another error that says you cannot borrow values mutable. That will be telling you that why it's saying that because the format float itself is it is mutating, because the moment you call format float, it will change the data that you passed to this object into this value. So that is called mutation. So you have to tell Rust that, you know what, I'll be doing a mutation. So this is more of a Rust thing than a kariRS thing. So you have to make this one a mutable variable. It needs to be mutable. So when you make it a mutable, then kariRS is the Rust is happy, and if Rust is happy and kariRS is also happy, then you end up being a happy guy in your code. So now this one, when I write 3 here, it means how many decimal points do I have. Now for example, here I have already 3, so it won't affect. But if I could add something like 8, 9 here, let's see whether we will get all of them. Let's save that. Let me go here. Let me clear and try to upload the program. Let's go to the monitor. Now you can see what we get. We are getting 8976.0000. So you might ask, okay, what's going on? We wrote 8976.54389, but we are getting 8976.000. Now let's try something else. So these are a puzzle I want you to see. Some things we take them for granted from other places, but I want us to see this. Now actually for this float here, I'm going to explicitly make it an F32, or maybe I could make it a 16-bit float. I think a 16-bit is lighter for the microcontroller. And F16, let's try F32, so that we cannot fight with Rust. We want to deal with kariRS, not Rust currently. So let's try the F32, which is much more lighter. The previous one was using the 64-bit float, which we know is very heavy for a microcontroller. It takes a lot of space and requires a lot to even use it. So let's now just change that side, and again we check. We keep checking. So we see we still have the same 8976.00. So hope you are noting out everything. So when you are creating a float data, I have to show you the issues so that you know how to maximize your program. So whenever you are creating, this is float data. whenever you are creating this, it's good to always give it a type here, F32, or maybe you could even try F8. But again, F8 is currently not supported. It's if you look at F8, you'll find that it's not supported. So you can usually have an F16 and above, maybe 0.7. But again, for carry string, so you can see now this is more of Rust issue than kariRS issue. So always write it as F32 to avoid it being made an F64. Tell it to be an F32. So, but that still doesn't solve what you are seeing. This is 8976.789. We actually save that. Now, when we give it this way, we are not finding the actual. These numbers become zeros. So I want to show you. If I shorten it, you won't get what I'm trying to get into without going to the actual solution, because it's very important. Now, this is the format float part, and you can see it takes the value which we are giving, and then it takes the decimals. Yeah, and we want just to see, and then it returns whatever we have as a string, and literally all that is what we are basically having, but we are finding that we are not getting the correct values that we gave. Let me give on the monitor. We are having 8976. So here's the catch. So literally, let me add another print statement here for you. So here I'll just say, I'll just get rid of this and create a variable. Let k and I'll call that function there. There is also called float done. Float data string don't update sorry for that. So we can usually so when you do that, so here we need to make it mutable. So Rust will fight for us because of the borrow checker. So we literally would just take whatever we have here and copy it there, and Rust is happy. literally. That is more of a raster issue than kariRS issue. Now let's upload this code. Be covering in depth about this carry string thing and the issue and the kind of issues you can learn into and how it solves them. I think we need to continue that session about this thing because it is much more deepness into this thing. Because I'm sure even the functions like these functions I'm calling here updates and all these, you might not be familiar with them, and it's good to ensure that you have a clear understanding and a good even understanding of this because it's very influential in various kariRS programs. For example, when you'll be dealing with LCD programming of this string class will come in very handy, and understanding it will make your life easier when dealing with such kind of displays. So let's try printing. So we can see we have 8976.000, 8976.000, 8976.000. Okay, so now I'll take you through the carry string and show you how to solve this issue that we've done step by step, because I want us to see all the total issues that we have with this carry string. So again, you've seen that we've been able to print the floats, but again we've seen there's an issue of some digits being omitted out. And I've showed you the part of the various things that I've showed you, because sometimes the reason I've added this printed statement here, this one, is because someone might say, oh, maybe the issue is having to initialize with a 0, and so if you feel that is the issue, you would come up and try to use the update function. Now I've also realized if I start adding more functionalities here and explaining it to you, then we might be going out of the serial. So we'll continue from here to understand about the carry string itself. But from up to where we have reached, is there anyone with a question about the serial side? Anyone with a question about the serial communication so that we can wind up with the session?
I'm good, thanks.
Okay. Um, so if you feel lost with anything about this carry string, I'll be covering it fully in the next session. So we'll actually come and show you the how we'll fix this, but I won't go straight into the solution. I'll first show you a couple of things about carry string so that when I'll be giving you this solution, you'll be seeing it will help you even appreciate even what others in other frameworks have done to curb with this kind of issues. So if there's no other question, I thank all of you for showing up, and even not just showing up, but even staying to the very end of the session. Paul, I've also noticed you've been persistent, so congrats for that, and thank you so much for attending. So I wish you all the best. Till next time.
Thank you and enjoy Valentine's tomorrow.
Okay, thank you too.